Hey, I'm Ozgun. I'm one of the technical founders at CitusData, and I'm really excited to be here. Today, I'm going to talk about the trends we see in the big data space, what we think makes PostgreSQL unique, and how we at CitusData scale PostgreSQL out. To start, let's rewind back 10 years and look at the data landscape in 2005. Here, I have a very simplistic diagram. On the x-axis, you have different workloads, and on the y-axis, you have different data types and how much structure these data types enforce. And the idea is, 10 years ago, databases used to be simple. You needed data warehousing, use an RDBMS. You needed real-time analytics, short insert, update, and select commands, or highly transactional workloads. The answer was simple: use an RDBMS. And then boom, data exploded. The idea in this graph is the amount of data captured in the world, thanks to the internet, your cell phones, and little devices, far exceeded Moore's law. And a single machine just wasn't enough to keep up with this data growth. So first companies such as Google, Amazon, and Facebook, and then others, started trying out new technologies. This led to a fragmentation of databases. If you had lots of data, you ended up using many and very different solutions. On the operations side, several document store databases have emerged. Then new SQL databases came back into the picture to bring SQL. On the analytics side, we saw Hadoop emerged. People started using HDFS, MapReduce, and Hive. People also started using proprietary MPP databases. And this is crazy, because for each new technology, you had to train new people, have them understand how each database works, have them maintain and debug that database, and have that database interoperate with other databases. And customers don't want to operate and maintain many separate databases. They want things to be simple, familiar, and reliable again. When we went and talked to customers with big data deployments, we asked them what they wanted. We received 3 groups of answers. First, my database should be able to handle multiple workloads well, both operational and analytic workloads. No one thought MongoDB was a realistic solution to replace their Hadoop cluster. Second, I want SQL with a twist. Some of my data is semi-structured, and I want to be able to query that semi-structured data too. Third, I don't want to start from scratch. I want to be able to use the existing tools and then the existing features that are written by others. And I want all of that to just work. And if you go and talk to these customers, you will see that all of them agree that PostgreSQL is that database at the single node level. PostgreSQL's operational analytic performance has been increasing steadily with each new release over the years. This diagram runs the TPCB benchmark on the same machine across different PostgreSQL versions. The blue line at the bottom is PostgreSQL 7.4 10 years ago, and the purple line at the top, that's almost 10 times faster, is PostgreSQL 9.2. Thanks to all the cool work the community has done over the years, PostgreSQL can do operational and analytic workloads really well. PostgreSQL also has extensive SQL coverage and data store and JSONB data types and indexes and operators for these data types. Also, there are 150 official extensions publicly available. For example, if you want to quickly calculate the number of unique visitors to your website over different time intervals, there is a hyperlog extension to do that. So if you can't express what you want to do in PostgreSQL, you probably can't do it with any other database. And when we're talking about the ecosystem, PostgreSQL is killing it. This is a survey from a developer website called Hacker News. This yearly survey asks, what database is your company using? On the left-hand side, you see survey results from 2010. On the right-hand side, you have the same survey results from 4 years later. And when you look at these 2 surveys, you see 2 differences. First, PostgreSQL's usage has tripled in 4 years, far exceeding any other database. Second, in 2010, MySQL had more usage than MongoDB and PostgreSQL combined. Fast forward 4 years, the news is PostgreSQL has more usage than MySQL and MongoDB combined. We talked about 3 properties that are important: operations and analytics, expressiveness, and the ecosystem. The challenge is, how do you keep these 3 properties while also scaling out? This is really, really, really hard. The truth is, you can't scale out a heavy write workload in the same way you scale out real-time analytics. You need fundamentally different query executors and dynamically choose among them based on incoming queries. Second, you can't do this half-hearted effort. You need to have the full theoretical framework to plan and optimize distributed queries to minimize network I/O. And finally, and probably most importantly, you can't fork the database. If you do, you lose the entire ecosystem. Thankfully, PostgreSQL has an extension framework that lets you get full cooperation from the core database without forking it. This is how those three properties look scaled out in a picture. For unified analytic and operational workloads, we have three different executors: a short request executor, a real-time executor, and a task tracker executor. For expressiveness, we create a logical plan using distributed relational algebra. We then optimize that logical plan, convert the optimized logical plan into a physical plan. And finally, we don't fork, but instead extend the database using these PostgreSQL extension APIs. That way, we get to keep the entire ecosystem. Here's an example of how all of these boxes work nicely in real life. CloudFlare is a global content delivery network and DNS provider. More than 5% of the global internet traffic flows through CloudFlare. There are 2 million businesses on CloudFlare, and each one of them looks at real-time dashboards to understand their website and network traffic. This entire data for all of these businesses is served from a CitusDB cluster. This cluster also uses the hyperloglog extension that enables CloudFlare businesses to see unique thread counts to their websites over varying time intervals. And some other example customers that use cool PostgreSQL extensions. Newstar is a publicly traded company that uses the pgshard extension for real-time ingest and CitusDB for real-time analytics together. Heap stores terabytes of data in memory in semi-structured and compressed format. Agari uses custom data types for real-time security. Migros uses geospatial data types, and there are many others. We're keeping calm and scaling out Postgres. Thank you.